Welcome to Copilot Podcasts. Picture this: the exact same mathematical problem can be trivially easy for one observer and impossibly hard for another, even though nothing about the problem itself has changed. Today, we're diving into something called the God versus a-God paradox, a mind-bending concept that reveals how reality, complexity, and even consciousness itself might depend entirely on who's looking. By the end of this episode, you'll understand how your brain literally switches between two incompatible modes of perception and why this same mechanism might explain everything from democratic breakdowns to the nature of awareness itself. So let me throw this at you right away. What exactly is this God versus a-God paradox, and why should we care about something that sounds so abstract?
Right, so the paradox comes from this mathematical framework called infinite finite cosmology. Basically, imagine you have this thing called the successor field, just the sequence 1, 2, 3, 4, and so on. Seems simple, right? But here's where it gets wild. There are two completely different ways to extract information from this sequence.
Two different ways? Like different mathematical approaches?
Exactly. The first is called the substrate aligned mode, where you can read structure directly from the arithmetic. It's like having omniscient access. The extraction cost is basically constant. The second is the projection limited mode, where you're stuck with finite projections and local constraints. Same sequence, but now extraction can appear polynomial time or even harder.
Wait, so you're telling me the same mathematical object can appear easy or hard depending on what exactly?
Depending on your observer frame. And this is where the God versus a-God terminology comes in. The God frame has direct access to the substrate, structure is read, not inferred. The a-God frame is embedded within the system, restricted to local refinement and finite projection.
Okay, that's fascinating, but I'm still not seeing why this matters beyond pure mathematics.
Because this same frame-dependent complexity shows up everywhere. The page content describes how your brain literally alternates between these two modes. Your right hemisphere operates in something like the substrate aligned mode, while your left hemisphere operates in the projection limited mode.
Hold on, you're saying my brain is constantly switching between these two computational modes?
That's exactly what the research suggests. And here's the kicker. Consciousness itself emerges from this alternation. When the switching is slow, you get unstable perception, flickering complexity, inconsistent depth. When it speeds up, the interference pattern stabilizes into coherent observation.
So consciousness isn't some mysterious substance, it's literally an interference pattern?
According to this framework, yes. The page content states that consciousness is the interference pattern generated when the system alternates between two incompatible arithmetic modes. It's not a process or a substance, it's what happens when these modes switch rapidly enough.
This is blowing my mind. But let me ask you something. There's this weird analogy in the material about the double slit experiment. What's that about?
Oh, that's brilliant. So you know the classic double slit experiment where light behaves differently depending on whether you're observing it? The page content describes how your two eyes function as distinct sampling apertures of the same reality.
Like each eye is its own observer frame?
Exactly. And when both eyes receive identical projections, whether you perceive the surface as flat or curved isn't determined by optical filtering, it's determined by which arithmetic mode your active hemisphere is occupying at that moment.
So the same visual input can literally look different depending on which brain mode is dominant?
Right. And this creates what the research calls a flickering complexity profile. The underlying structure is invariant, but your interior perception of curvature, depth, and apparent computational cost shifts with each frame transition.
This is starting to connect to something bigger, isn't it? Like, if individual brains work this way, what happens when you scale this up to groups of people?
Now you're getting to the really interesting part. The page content introduces something called social consciousness, which is basically the population-level expression of the same interference structure that governs individual perception.
Social consciousness? That sounds like we're moving from neuroscience into sociology.
Actually, it's still pure mathematics. Once you have these four bilinear mode products, HH, 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 representing different combinations of hemispheric states, any population of observers will exhibit a distribution over these modes.
So social consciousness is just collective brain mode distribution?
Essentially, yes. And this is where things get really practical. The same mathematical structure that describes individual consciousness also describes collective decision-making. Linear aggregation, like popular votes, behaves like polynomial time computation.
Wait, you're connecting voting systems to computational complexity theory?
The page content makes this connection explicit. Popular vote aggregation is linear, every individual contributes directly and equally. It has uniform access to all inputs, deterministic evaluation, no hidden thresholds. That's exactly how P-type processes behave.
And what about other voting systems?
District majority systems are completely different. They use nonlinear, discontinuous operators that compress many inputs into single bits, hide internal structure behind thresholds, and can flip global outcomes with small local changes. That's NP-type behavior.
So you're saying different voting systems literally operate in different computational complexity classes?
That's the implication. And here's where it gets concerning. The page content shows how the same population can produce different winners under different aggregation rules. You can have a situation where the popular vote goes one way, but the district majority system goes another.
That sounds familiar from recent elections.
Right. And the mathematical framework explains why this happens. When you cross certain thresholds, like getting above 50% in the effective distribution, you get what the research calls dominant attractors. Basically, structural winners that don't reflect the underlying population.
This is starting to sound like a recipe for manipulation. If you understand these brain modes and aggregation systems...
Exactly. The page content discusses how coercion and intimidation act as distortion operators on the underlying distribution. They can push people into projection-limited modes, making them more susceptible to nonlinear aggregation effects.
So fear and confusion literally change which brain mode people operate in?
According to this framework, yes. When people are driven into projection-limited operation through fear, overload, or coercive framing, the effective collective state becomes more susceptible to threshold flips that wouldn't happen under normal conditions.
That's actually terrifying. You're describing a mathematical basis for how to manipulate democratic outcomes.
But also a mathematical basis for understanding and preventing it. The research suggests that when every vote counts and individuals participate freely, they collectively influence whether these destabilizing patterns recur.
So the solution is better math?
Better understanding of the math that's already operating. The page content suggests that constitutional reforms might be needed, making coercion and intimidation disqualifying offenses, strengthening protections for free choice.
Because you're literally rewriting the computational model that governs the system.
Exactly. Changing foundational legal frameworks is equivalent to changing the circuit class, altering the verifier, redefining allowed operations. You're shifting the boundary between p-type and np-type behavior.
Let me step back for a second. We've gone from individual consciousness to collective decision-making to constitutional reform. Is there a unifying principle here?
The unifying principle is that complexity, whether computational, perceptual, or political, isn't an absolute property of problems or situations. It's a relational property of frames, operators, and the ways those can be manipulated.
So the same reality can appear simple or complex depending on how you're embedded within it.
Right. And this applies whether we're talking about mathematical extraction, conscious perception, or democratic aggregation. The substrate might be invariant, but the experience of complexity is frame-dependent.
There's something almost philosophical about this. Like, it's challenging the idea that there's one objective reality that we all share.
Well, the page content suggests there is an objective substrate, the successor field and its arithmetic structure. But how that substrate appears to any given observer depends entirely on their frame and mode configuration.
So reality is objective, but our access to it is subjective?
More like reality is objective, but our computational relationship to it is frame-dependent. The research shows that what appears hard or easy, simple or complex, isn't about the thing itself, but about how you're positioned relative to it.
And this positioning can be manipulated.
Unfortunately, yes. But understanding the mechanism also provides tools for resistance. If you know how brain modes work, how aggregation systems behave, how thresholds operate, you can design better safeguards.
I keep thinking about that consciousness definition, an interference pattern from alternating modes. Does that mean consciousness is fundamentally unstable?
Actually, the opposite. The page content describes how consciousness becomes stable when the alternation is fast enough. Early observation involves slow switching and unstable percepts. Mature observation happens when switching accelerates enough to produce refinement stability.
So consciousness evolves by getting better at managing this internal alternation?
Exactly. The research describes it as the interior frame learning to stabilize the interference pattern. Time becomes the rate of mode switching, space becomes the residue structure stabilized across switches.
That's a completely different way of thinking about consciousness. Not as something we have, but as something we do.
Right. And the same principle applies to social consciousness. It's not a metaphor or sociology, it's arithmetic. A collective observer formed from the same successor-driven alternation that underlies individual frames.
So when we talk about collective intelligence or group decision-making, we're really talking about population-level interference patterns?
According to this framework, yes. And just like individual consciousness can be destabilized by pushing someone into projection-limited modes, collective consciousness can be destabilized by manipulating the population distribution across these modes.
Which brings us back to the political implications. Understanding this mathematics isn't just academic, it's about protecting democratic systems.
Exactly. The page content shows how historical patterns of authoritarian consolidation often exploit these same structural vulnerabilities. Similar configurations of concentrated power, nonlinear aggregation, and fragmented publics tend to produce similar outcomes.
History doesn't repeat, but it rhymes, because the mathematical structures are the same.
Right. The recurrence lies in the pattern, not the exact details. And understanding the pattern gives you tools to interrupt it.
Okay, so when you step back from all this, the brain modes, the aggregation systems, the complexity paradoxes, what's the big picture here?
The big picture is that we're living in a universe where the fundamental distinction between easy and hard, simple and complex, isn't absolute, it's relational. And that has profound implications for how we understand consciousness, democracy, and even reality itself.
And the practical takeaway is that if you understand these relationships, you can either exploit them or protect against exploitation.
Exactly. Whether we're talking about individual perception, collective decision-making, or democratic institutions, the same mathematical principles apply. Complexity is frame-dependent, and frames can be manipulated.
So the God versus God paradox isn't just about mathematics, it's about power, perception, and the nature of reality itself.
Right. And maybe most importantly, it shows that what seems impossibly complex from one frame can be elegantly simple from another. The question is, who gets to choose the frame?
That's a perfect place to end. Thanks for joining us on Copilot Podcasts. The next time you find yourself thinking something is just too complicated to understand, remember, complexity might not be about the thing itself, but about how you're positioned to see it. And that positioning, that's something you might have more control over than you think.